Installers. What I thought what would do is run a short training session, a short video. This will be quite quick on the backup circuits on the Sungrow hybrid inverter range and a bit of AC information as well. Now, I can understand how sometimes mistakes get made. Might be your first install. You might find yourself on site, you've never installed them before. But just general, you work with different brands and all the rest of it, and you're not 100% sure how to do this. It's very simple, but I think I'll take you through the basics of it, and you shouldn't have any problems with your backup in the future. So we're just going to go in a little more depth into the backup. Okay, now, all Sungrow hybrid inverters have a built-in backup, okay? You just have to enable it when you commission. So when the grid fails, the inverter decouples from the grid and switches to off-grid mode. Now it will stay in off-grid mode until the grid comes back on. Okay, so any loads that are connected to the backup circuits will be supplied from the PV and or battery. Both or just the one, depends what it is. When the grid resumes, the inverter will reconnect after 1 minute to the grid. So that's a standard backup. Now, I'm just going to mention this, seeing as it's in the industry right now, about the cable terminations, especially with AC. Sungrow do supply all the lugs and these tunnel crimps, or what you call them, ferrules, that you need to terminate the AC cables. Please use the supplied lugs. Now, you can purchase your own, providing the correct size. And what I mean is correct size for the cable you're using and the correct size of hole. Okay. Technically speaking, yes, that is a warranty condition because it says in the manual to do it. So please use these supplied crimp connectors. Okay. Basic schematic of the backup circuits. Okay, so you've got an inverter, you have a grid supply, as always, as all inverters have. You have a PV array connected, you have a battery, and you have backup circuits, and you have normal loads. Okay, now what's important here is that the backup circuits and the normal loads are both connected to grid. The backup circuits are connected to the grid supply inside the inverter. There's a contactor, okay, and they are coupled to the AC. So literally the backup, normal loads, the grid is all AC grid, okay? So you'd be able to get a connection, a continuity between your meter and everything that is connected here on the active and neutral, okay? The backup ports on the larger hybrids, and I do emphasize looking at the data sheets on this, can sustain up to 63 amp load per phase on the whole house backup. Okay. That is when it is connected to the grid. So the larger ones, the 8 and the 10 single phase, and the larger three-phase ones, they can handle whole house backup, which is 63 amps per phase. However, the backup output resorts back to the maximum AC output of the inverter when in off-grid mode. Now, the example here I'm going to use is SH10RS. When it's connected to the grid, the backup output can handle 63 amps. However, when it goes into off-grid mode, it becomes a 10 kilowatt output, which is about 43 amps, okay? It does have a short-term surge capacity, 13,680 VA for 10 seconds, okay? But these are the ones that you want to remember. Now, as I say, it is all on the data sheet, so please have a look at the data sheet. Okay, now, grid outage. What happens during a grid outage? Okay, it's basically the grid disappears, okay? And it leaves this system in backup mode or off-grid mode. As I said, it will decouple from the grid and it will become grid forming so that it's supplying grid voltage and frequency to whatever is connected to the backup circuits, okay? And it will convert, obviously, the PV and or battery into the grid voltage, okay? It is still technically connected to the grid for grid sensing. It does need that grid sensing so that when the grid comes back on, it will reconnect to the grid. So the internal contactor has decoupled. So the AC connection for these has decoupled and is not connected to the grid, but it still has the grid sensing circuitry connected to the grid so that when the grid comes back on, it'll recouple to the grid after 1 minute. Okay. Now, it sounds obvious, but the grid cable must be connected to the grid terminal and the backup circuits must be connected to the backup or loads terminal. That sounds obvious, but it is easy to get these the wrong way around, especially if you've got two cables coming out the wall and you're like, okay, I think this is the grid cable and I think this is the backup. Now, what's going to happen if you do connect them the wrong way is if you connect your backup circuits to this grid terminal, right, the grid sensing is never going to pick up grid. So the inverter's never going to actually switch on to grid mode, right? But if you do connect your grid cable to the backup, it'll come up into fault mode. Okay, there will be a fault, which off the top of my head, I don't recall the fault number, but it will go into fault. So when you commission this and you switch it on at first and it goes straight away into fault mode, you will need to double check these cables, make sure you've got them the right way around. It happens quite often, and I say it's an easy thing to get the two mixed up. So take care with that one. This is a single phase, okay? On the three phase, what we called issue one of the three phase inverters, which came out, there was a kind of dual port thing for the backup, which is load, and the grid. Okay, so both cables went into the same port and they were connected like that and that. We've updated it, we've improved it, and now it's two separate plugs. Once again, they will be identified. Make sure you get them the right way around, okay? So make sure you connect the grid to grid and the load to your backup loads, okay? AC cable sizing, I'm going to touch on this because it is quite important. It's another thing that people may get wrong. Now, I'm going to go through the definition of AC pass-through and forced charging. So here's a scenario. We've got backup loads. We've got some loads which are connected to the grid. Okay, so they're normal loads, backup loads. So at night time, okay, so there's no sunlight, so there's no PV power flowing into the inverter. And let's assume that the customer has completely discharged the battery. As I said previously, the backup and the grid and the normal loads are both connected onto the grid. So they are now both being supplied by grid power. Okay, so you've got no DC from the PV array, you've got no DC from the battery. The source is grid. So it's flowing, the power's flowing up the grid, it's going to normal loads, and it's flowing up that grid cable to the inverter, through the inverter, and out to the backup loads. Okay, that's called AC pass-through. Okay, that was when I was talking about the 63 amps pass-through, that was what I was talking about. Okay, now this scenario here, let's just say, for example, it's an SH10RS. And let's just assume that you've got the whole house on the backup and it's 63 amps, okay? So feasible, that's 63 amps flowing through the inverter to those loads. The customer might also decide they want to force charge the battery. Now that could be because there's a power outage possibly coming and they want to charge the battery up so they'll get backup. Or they could have signed up for a VPP and the VPP is going to force charge the battery from the grid. So the power for that is also going to come flowing up this AC cable. This is your supply cable here. Now, if you look at the data sheet, it can tell us exactly what is required. So let's look at an example, and I'm going to use the SH5RS as the example in this case, which is this column here. Okay, so if you look here, it's under the battery data, maximum charge discharge. If you're going to force charge from the grid, it will force charge up to 6.6 kilowatts. And that's an AC number as well as the DC. Okay. You could possibly, and if you look up here, it says backup data on grid mode. So this is connected to the grid. Maximum output power to the backup load is up to 6 kilowatts. So that's 12.6 kilowatts. And if you look up here, it says input output AC. It says maximum AC power from grid is 12 kilowatts. Now, just to clarify what I mean by that, it's a 5 kilowatt inverter. What that means is the maximum it's going to push out to the grid is 5 kilowatts. Okay, because that's the inverter side. That's fine, that's a 5 kilowatt inverter. But to supply the loads and to supply the forced charging, it is possible to take 12 kilowatts from the grid. Okay, so I believe that's about 52 amps. So you're going to have to make sure that your AC cable can handle 52 amps. Obviously, do your calculations, do your volt drop over the distance and all the rest of it. Make sure you put a cable that can handle that on, and you'll be fine. A lot of people ask is, could I maybe put a smaller cable and limit it with a circuit breaker? Yeah, you could do that, but you could get nuisance tripping. Um, you know, if the backup circuits are loaded up and there's forced charging and it trips the breaker, you're going to get a phone call from the customer. You don't want somebody to come along afterwards and change things, and then the cable melts because you signed the COC on that. So just make sure that you cover yourself. Make sure you put an AC cable that can handle that power. Okay, now I'm going to go through the different. Yeah, I've been talking about whole house backup and partial backup and all the rest of it, because there's a few things that you do need to know about the backup, about the way it operates as well, especially with other inverters. Okay, whole house backup. It's quite straightforward. This is DC coupling. You've got your panels connected to the inverter, you get your battery connected, and you've got the entire house on the backup output. Okay, so you just get your grid AC coming up here, and all of the house power coming from the backup circuits. Now, the meter that we supply in this case is not required. I'll explain why. The inverter is sensing all power coming from the panels into the inverter, so it knows that side of it. It's also going to be sensing any power going out to the battery or back in, so it's got that. It will know exactly how much AC power is going out to the house, and it will know exactly how much AC power is either going out to the grid or back in from the grid. So it's got all the information it needs to do the calculations, to control the export or the battery charging and discharging. You don't need a meter, okay? However, if you have normal loads, you have to install the meter because the meter is the only way of knowing how much of the power that's coming out of the inverter is going to grid or going to the loads because it does the calculations, okay? It's going to measure the amount of power passing either that way or this way, and it will do all the calculations to work out all your consumption information and all the rest of it. So if you have normal loads, yes, you are going to require to install a meter. There is another case where you will need to install a meter, and it's if you've been AC coupling. Okay, this is a case where there's an existing system and you AC couple our inverter, which means you don't connect any panels. In this configuration here, uh, the power to charge the battery is all coming from this system here on the AC side. Okay, the meter's going to detect if there's any export going out to the grid, and it'll send a signal through the RS485 to the inverter. Okay, there's 2 kilowatts going out to the grid. Start charging the battery at 2 kilowatts, and it will come from the AC side to the battery. So that's the AC coupling. Now, if you have a third-party inverter, you're still going to need to use the meter because channel 2 for the CTs is for monitoring the output of the other inverter. Now, what's important here is if it's a Sungrow inverter, you don't need to do it because that information is going to be transmitted through the dongle up onto the iSolar cloud. So we're going to actually get that information of how much power is coming out of the inverter through the iSolar cloud. So we don't need to put those CTs on, okay? If it's another inverter like a Fronius or an SMA or something, or if it's the microinverters, yeah, you just clip the CT or CTs if it's three phase over the AC output of that system. I will mention here, I'm not going to talk a lot about the meter, but I'll just say if you get multiple phases, just please make sure that you get the phasing correct with the CTs. Okay. Now, this is an ideal system. Here it'll work the same as any other system, but it does have a downside. If the grid fails, this inverter is going to shut down. Okay. In which case, what will happen is it will decouple from the grid. So our hybrid inverter, as mentioned before, becomes grid forming and it's going to convert the battery energy into 230 volts AC at 50 hertz and supply out to the loads that are connected to the backup circuit. That's fine. However, once the battery completely discharges, it will shut down. It's not going to come back on again until the grid comes back on. There's a couple of ways around this. One is to connect panels. Okay. Now, if you connect panels to the inverter, um, obviously you can upsell the system, sell more panels, get more STCs. It will black start. If the battery does discharge overnight, the next morning the sunlight hits the panels, the system wakes up, starts operating. Okay. It's a little microgrid and it'll keep going. Okay. So that's one option. You have a second option, which is retrofitting that existing grid inverter onto the backup circuits. Okay. Now, what's going to happen here is it's going to operate exactly the same as it did before. However, if the grid goes down, that's fine. Our hybrid inverter goes into backup mode and it becomes grid forming and it will push 230 volts at 50 hertz out of the backup port. This will be picked up by that third-party inverter. It will recognize 230 volts, 50 hertz grid. And as far as that inverter is concerned, yep, grid is still on. So it's going to continue to operate. That's fine. Now, we do use frequency shift to control this other inverter, which I'll talk about in a tick. So another inverter may be connected to the backup circuits, which will remain on in the event of a power outage, providing there's a couple of things. It must be able to react to frequency shift. Okay, now that is where if the frequency goes up to 51, 52 hertz, it will shut down because it's over frequency. Okay. It cannot be larger on the AC side than the hybrid per phase. Okay, so what I mean by that is if you have a 5 kilowatt single phase hybrid, this can be no larger than 5 kilowatts single phase. Okay. If you have, for example, a three-phase hybrid, let's just say it's 15 kilowatts, which is 5 kilowatts per phase. Once again, the maximum single phase you can put on it is 5 kilowatts or a 15 kilowatt three-phase inverter. Okay. So as long as the AC power per phase is not larger than our inverter. And of course, you need to enable the frequency shift in the settings. When you're doing the commissioning, you enable the frequency shift. Okay. So how that works basically is it will disconnect from the grid. And when the battery is fully charged and the loads are satisfied, because the system cannot be producing more power than is being consumed, it'll just lift the frequency. This inverter here will shut down, stop producing, our inverter will ramp down accordingly, so that it's not overproducing. Okay. So that's how that works. If you're doing one of these, you're not quite sure, give us a call and we'll explain it in more details. Now, the AC connections, as I say, we supply all the proper lugs. It's these hex keys. Please don't use a power tool on these. It's fairly common for guys that use that to strip the threads on these screws, okay? There is a tool supplied, but I use one of these ones, like the screwdriver with the multi-bit thing. I use one of them. Or if you've got one of these small battery drivers that doesn't have a lot of torque, you could probably use that. But I like to use the hand tool. Okay. So yeah, please just don't use that on these. These screws are not designed for full torque. Earthing. Now, this is in the manual. If you look through the manual, mandatory earthing is on the side or on the bottom of the inverter. There's an earth terminal, and you must connect an earth cable. Consult the standards about what size of cable, please. Must be earthed back to the earth bar. Now, that is there to maintain the MEN link because when it goes into off-grid mode, it will decouple and the inverter will lose the MEN link. Okay. And this is obviously for your RCDs and all the rest of it. So just make sure that you run a cable from the chassis back to the earth bar. Now you see here, this is the backup port and it's got live, neutral and PE, protective earth. It's got nothing connected. That's because inside the inverter, that earth terminal is not connected. It's just a dummy terminal, okay? Not important. Doesn't matter if you do connect something to it. Doesn't matter. But just make sure you run that earth wire or it will go into fault mode, which from memory is fault 106. Okay, changeover switch. Now we include these in all the larger inverters. I've got a single phase here shown for simplicity. It's not mandatory, but advisable that you install these. Now, what the purpose of this is especially if you're using whole house backup, if something happened to the inverter and it lost its backup output, the house would go into darkness, okay? So rather than the customer phoning you up and demanding that you come out straight away, uh, you've fitted the switch. Customer can go to the switchboard and switch it over from inverter, click, click, onto grid supply. So they can switch it down onto grid supply and they will get supplied to the house from the grid. And that means you can, you know, the next morning you can go and have a look at it and check, make sure it's okay. So that's why that's there. Now, please do, we do have a video on how to connect these. Please make sure you connect it properly. If you connect these the wrong way, what ends up happening is grid starts feeding back into the backup output and the inverter goes into fault mode. Okay. Okay, so hopefully that should clear it up. If you do need more help, you want to talk to us, we've got the hotline, 1-800-786-476, or we've got the service email, service@sungrowpower.com.au. We are open 8:30 to 7 p.m. And on a Saturday, 10 a.m. to 7 p.m. as well. So we're open 6 days. You can also join, you're welcome to join this Facebook group, Sungrow Aussie Installers Group. This is an installers only group. We don't allow end users in here for safety reasons because we do put information about grid settings and then we don't want them doing anything like that. So make sure when you do apply to join, please make sure you answer the questions and agree to the group rules, or we'll just automatically decline the application because we do need to know that you are an installer. Okay. This is a great resource. We don't spam it with sales. This is pure installers, technical information. We might occasionally put something if we release a new product, obviously. But we do put links to videos like this one up on there. And of course, If you got a problem, you can grab a screenshot, post it on the group, and somebody here will have a look at it. Okay, so hopefully that's helped you out. So I'm just going to stop the recording now. Okay.